Another data distribution is called the binomial distribution, and that deals with trials where there are only two possible outcomes, true or false. A customer might either sign up for or not sign up for your company's mailing list, for example. In this movie, I will show you how to calculate the probabilities for outcomes described by the binomial distribution. So we will need our chance of success and the number of trials, that is, the number of customers who appear, and we can use those calculations to graph the likelihood of a specific number of customers signing up. With that introduction, I will switch over to Excel. My Excel sample file is 0405 binomial, and you can find it in the Chapter 4 folder of the Exercise Files collection. In this workbook, I have a worksheet with a graph that will show the sign-up percentage based on calculations we make in the table on the left. We have the two pieces of information we need in column B. So in B1, which is already selected, I have the probability of success, and we're assuming that a customer will be 35% likely to sign up for our company's mailing list if we present it to them. And we are going to work with 20 customers at a time. And from there, we can evaluate our data. To create our formula, I will click in cell B5, and this is an Excel table. So when I enter this formula in the first row of this column, the formula should be copied down. So I will type in equal sign, and the function we'll use is binom.dist, so binom.dist. The number of successes is in cell A5, so the first calculation will ask about the probability of getting 0 successes, in other words, no one signs up, and a comma, then the number of trials, and that is in cell B2. I don't want that reference to change, so I'll press F4. That's Command T on the Mac, then a comma. Probability of success, that's in B1, so I'll click there, and again, F4, comma, and a question of whether we want the probability of getting that value or less, or the specific value exactly. In this case, I want the specific value, so I will highlight false for the probability mass function, also called the point probability. Press Tab, right parentheses, and enter. And the formula didn't copy down, but if I click the action button that appears, that's the autocorrect options button, and then click overwrite all cells in this column with this formula, then I get the updated calculations and the chart that you see on the right. Looking at the data based on 35% probability of an individual signing up and 20 as the number of customers we approach, we can see that the most likely outcome is 7. And that makes sense because 0.35 times 20 is 7. So it's very unlikely that no one will sign up. And most of the time it looks like we will have between, say, about 4 and 11 individuals signing up. And again, it appears that our most common value will be 7. If you want to determine the probability of a specific number of successes or less occurring, you can change the last argument from false to true. So I will double-click in cell B5, which contains my first formula, backspace far enough so I get true, the cumulative distribution function. Press Tab to accept it, enter, and this time the formulas in the column did update. So as you can see, the probability of getting 5 individuals or less, or fewer, I guess, is about 21%. And then 6 or fewer is about 40%, 41 in this case, 60% for 7 or less, and that continues on up to 20. And you can see that there is not much of a change in the probability between getting 14, so that's 96.97%, and 15, which is 99.995%. So it is very unlikely that we will have anything more than about 10 people showing up or signing up in a particular hour. Analyzing data using the binomial distribution lets you determine the likelihood of achieving certain results when faced with a series of yes or no trials. If you're not hitting your targets for mailing list sign-up or sales opportunities, you should consider whether your approach needs to be changed or if your expected success rate is too high.